All right, guys, we are here for your first video of the new year. And so we're going to get right to it. We are going to start off with an Algebra 1 TEK that you learned about how to solve systems. Now, what a system is equations of two or more that will be graphed and you will find the solution. Now, in this case, since we're only going to be dealing with two equations right now, the solution is just going to be a coordinate point, x and y, of where they intersect, okay? So what I did is I gave you some steps to solving. Please make sure that you're writing down everything that's on this slide and the next. Feel free to stop it at any time and re-listen or have time to write what's on the slides because I will be checking them. Okay, first of all, I just want to make sure that whenever you are using the graphing method to solve systems, because there are multiple ways to solve systems, but we are going to stick to graphing today, you must make sure that each equation is in the y equals format, okay? That is your slope-intercept form, y equals mx plus b, okay? Y equals mx plus b, okay? So make sure that it's in this form first, and that way it's easier for you to graph, okay? Because the next step is to graph the equation, okay? So remember to go ahead and start here. Start at your y-intercept, okay? And then use your slope to go from there. So if your slope is 3, that means you're going to rise 3, but you still have to run 1, okay? Once you have both of those equations graphed, you will then find the intersection, which will give you an x and a y. That is your solution, okay? Now, there are some different outcomes that could possibly happen. We could just have one solution, which is normal, okay? Two equations are going to cross only at one point, okay? Notice the slopes are different, and the y-intercept doesn't matter. They're going to be, it can be the same or not, okay? But if there's no solution, that means they will not intersect at all. So if you think about it, they're going to have the same slope, which means they're parallel. So this is a symbol for parallel, okay? That symbol right there means parallel. Also, your y-intercepts have to be different. Otherwise, they're going to be on top of each other, and that's a whole different situation, okay? So one solution, we have different slopes, and doesn't matter about the y-intercept. If there's no solution, that means they're going to be parallel, which means they have the same slope, but the y-intercepts have to be different. Now, if you notice that they're exactly the same equation, that means they're sitting on top of each other. So they're crossing at every single point. So you have an infinite solution in this case. There's a lot of solutions, okay? A ton of them. So you can't just pinpoint one. So you would just say that there's an infinite number of solutions. Now, for those of you that are visual learners, I want to make sure I show this to you on a graph. All right, we have intersecting lines, okay? This is one solution. You have one solution right there, okay? If you notice that they're parallel, that means that the slopes are different, but the slopes are the same. Y-intercepts are different. Okay, if you have parallel lines, there are no solutions, okay? No solution. There's nowhere that they intersect. There's not a solution for both the graphs at the same time, or both the equations at the same time. Then we have what's called coinciding lines. This is a geometry term. Coinciding lines mean they are sitting on top of each other. So in that case, you have an infinite number of solutions, okay? Now, if you didn't already grab some graphs from the back table, make sure you do that now so you can go ahead and paste these in there. Okay, so we're going to solve each system by graphing. What does that mean? That means we're going to solve for the intersecting point, okay, if there is one. Remember, the first step on the previous page is to go ahead and put each of them into the slope-intercept form, y equals mx plus b. Okay, so I'm going to do number 1 down here. First, I have x plus y equals 5. Now, that is not in slope-intercept form. I need the y to be isolated. Okay, so I'm going to go ahead and subtract the x on both sides. And what I'm left with is y equals negative x plus 5. All right, so that looks a little bit different from here, but all I did was switch around my terms, okay? So I had a negative in front of x, so I had to make sure I brought that down, and the 5 was positive, okay? So what does that mean? That means my slope is negative 1, which if we put it in a fraction, it's negative 1 over 1. And my y-intercept is 5, so that's my starting point, okay? So I'm going to go ahead and start graphing that first equation there. I'm going to start at 5. My slope is negative 1, so I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, and create that line there. That's going to go right through there, like so. Okay, so now we have a second equation that we need to go ahead and graph. And we have x minus y equals 1. Again, we need to rewrite this in slope-intercept form, okay? So let's go ahead and isolate the y. So let's subtract that x over. Now I'm left with negative y equals, I'm going to rearrange this over here, negative x and a positive 1. Now, if you recall, what's really in front of this y is a 1. And we can't have a negative y, okay, because that's not the correct form. So I'm going to divide out that negative 1 from every term. So that makes this 1y now, positive 1y. So 1y equals, a negative divided by negative is a positive 1x, and a positive divided by negative is a negative 1. So here I have y equals x minus 1. My starting point is negative 1, and my slope is 1, which is really 1 over 1. So from that point, I'm going to go rise 1 over 1, rise 1 over 1, rise 1 over 1, rise 1 over 1. Go ahead and connect that line. Remember, it's going to extend. And we notice that 2 of our dots have connected. And so we have one solution, and our one solution is at 3, 2. So it says solve each system of equations by graphing. We solved it. We have the solution. 3, 2, there's my x, there's my y. So if it asks for just the x value, you say x is 3. Okay, if it asks for the solution, 3, 2. All right, so moving right along, what we're going to go ahead and do is go to number 2. We have 4x minus 2y equals negative 8. And it looks like I put an x there, so I'm going to change that to a y equals negative 8. And luckily, our other equation is already in slope-intercept form, so that's convenient. I do need to isolate the y, so I'm going to subtract 4x over both sides. And I'm left with negative 2y equals negative 4x minus 8. Again, I did just flip around the terms. I did not change the value of them. Okay. At this point, I do need to get rid of that negative 2. So I'm going to divide it out all the way across. So that gives me a 1y. So 1y equals 2x plus 4. All right, so let's go ahead and graph 2x plus 4. 4 is my starting point on the y-axis. 4, I'm going to have a slope of 2, which is really 2 over 1. So I'm going to rise 2 and run 1. Opposite of rising 2 and running 1 is going down 2 and left 1. I'm going to put that other point there. Right there. And I have a graph. It's going to keep on going. Both ends, forever and ever. And my second equation is y equals 2x plus 4. I'm going to have my starting point at 4. My slope is 2, which is really 2 over 1. Notice how it's going to give me the same line. These are coinciding lines. these coinciding lines mean that we have an infinite number of solutions. So it says solve each system by graphing. The solution is an infinite number of solutions. All right. Perfect. So lastly, we have two equations that are already in slope-intercept form. Hooray! All right. So let's start at positive 2 on that first one. And our slope is -3, so really it's going to be -3/1. So I'm going to go down 3, right 1, down 3 more, right 1, create my line, like so. Okay, and then I have 2x minus 3, which means that I start at -3, put my point, and my slope is 2, which I'm going to use 2/1, so I have a rise and a run. So I'm going to rise 2, run 1, rise 2, run 1, and create that line. And you should notice that we do have one solution at 1, -1. And you can always double check yourself to make sure that you have graphed those correctly. Plug in a 1 for x and a y, and make sure that what you have is in fact true. So for example, if I bring this down, my y is -1 equals 2, my x is 1, and then -3. And I'm going to double check that this is correct. If it's not correct, I have done something wrong. I have not really found the solution. So -1 equals 2 minus 3. That is in fact a true statement. I do have the correct answer. All right, so you do have a formative assessment to make sure that you understand what's going on here. Please, please, please ask questions. I do not want to start off the year with any discrepancies, so please let me know if you need anything.